At the end of each module, I'm going to create an integration video, which should help you understand how to put all of the pieces together for this particular module. For the first example, we're going to take a look at a basic geometry problem, which is the calculation of a hypotenuse. And if you remember in geometry class, they talked about how if you have a right triangle and you have a leg 1 and leg 2, the hypotenuse, or the side across from the right angle, can be calculated by squaring leg 1, adding it to the square of leg 2, and then taking the square root of the result. So how might we code the solution to this problem using Python? Well, any program typically has three parts. It has the input, it has the process, and it has the output. You'll notice that in the first 6 lines, I have prompted the user to enter the leg 1 and the leg 2. That's the input to the program. You'll also notice that I have converted the inputs to floats because, of course, a leg of a triangle could be have a decimal value and doesn't necessarily have to be a whole number. The processing part has to do with the calculation. To find the square root of a number, you can raise it to the 1/2 power. So I take the quantity of leg 1, square it, add leg 2 and square it, and then I take that whole quantity and raise it to the 1/2 power, which is, as I've said, equivalent to taking its square root. For the output, we're going to have a fairly long statement. So I've broken it up into 2 parts, outstring 1 and outstring 2. You'll notice that in both cases they are F strings, so I've embedded leg 1 and leg 2 along with the appropriate formatting specification so that it will round it to 2 decimal places. And then in the output on line 18, I use those two and I add them together. Now this may seem strange because I told you cannot add strings, but what you can do is you can do what's called concatenate the strings. That is, it sticks the two together. This is preferable because otherwise our code for line 13 would run off the page, and we want to be able to see all of the code on our page. So by taking outstring 1 and adding outstring 2, this does not mathematically add them, it just sticks these two together so that I have one long string. Finally, in line 19, I do the output. So let's see this actually execute. When I run it, the first thing it asks me is for leg 1. So let's type in a length of 12. And let's make it 12.5 since it's a float. And then it asks me for leg 2, and let's say 27.6. Once I hit return, you'll see the output. It says for a triangle with legs 12.5 and 27.6, the hypotenuse is 30.30. You'll notice again, everything is formatted, everything is rounded to 2 decimal places, and the output looks fairly professional. In another example, let's take a situation where we want to convert seconds to hours, minutes, and seconds. So for example, if I ask the user to enter the number of seconds and she enters 9,453, how do we convert that to hours, minutes, and seconds? Well, we know there's 3,600 seconds in an hour. So that means if you do integer division, 9,453 divided by 3,600 will result in an integer of 2. And you'll notice the 2 slashes here. Again, that's integer division. So 9,453 seconds contains, in a sense, 2 hours. But we still have 2,253 seconds left over. So if we use those 2,253 seconds, and we know that there are 60 seconds in a minute, we can then find the number of minutes in 2253 by using integer division again and dividing it by 60. If we do that, we'll end up with 37 minutes. And that uses up most of the time, but we still have 33 seconds left over. So the result is 2 hours, 37 minutes, and 33 seconds. So how could we do this in Python? Well, again, all programs have 3 parts: input, process, and output. Now in this situation, the process is going to take the majority of our space because we really only have one thing to input, and that is seconds. If we ask the user the number of seconds, the input here is going to be an integer, that is a whole number. So we're going to convert this explicitly to an int. Again, there are 3,600 seconds in an hour. So if we use integer division and we take the entered number of seconds and divide it by 3600, we'll get the number of hours, which is, as we said, 2. But we still have to find the leftover seconds. Well, as it turns out, modulus can be used for this. If we take the number of seconds and mod it by 3600, we'll get the leftover seconds, which, as we said, was 2,253. So we have the leftover seconds, 2,253. Now we need to find the number of minutes. And so in line 20, we actually divide it by using integer division by 60, and that gets us our 37 minutes. If you then mod that leftover result by 60, you'll get the leftover seconds, which was 33. And if you print the result, you should see it in the correct format. And we used our friend here, the F string, which does a nice job of formatting. So let's run it and let's see how it looks. So if I enter 9,453 seconds and I hit return, you'll see the result. The result is 2 hours, 37 minutes, and 33 seconds.